So for the distributive property, we're going to be focusing on groups and multiplying everything inside the groups by the factor outside of the groups. So first, we're going to focus on terms. Terms are separated by adding or subtracting. So the first term is x, and then the second term is 2. So we're going to rewrite it up above with the 3x, and then the 3 goes to the second term also in the group. So we got 3x minus 3 times 2. The focus of these equivalent expressions and using the properties is to write the expression in another way that is equal. And how do we do that? We're going to multiply the first thing, 3 times x, and we can just write it as 3x minus 3 times 2, which is 6. So check for your answer to the right. Moving to the second one, we have the term 3 and the term x in the second expression. So we're going to move it up above and put a 5 with the first term and then put a 5 with the second term. And we just rewrite it. We're going to multiply 5 times 3 is 15, and 5 times x will just become 5x. Now, as a quick note, just to define and explain here, 15, this number is called a constant. And then the number in front of the variable that's multiplying the variable is called a coefficient. So coefficients multiply, constants are added or subtracted, and they are numbers by themselves. Moving on to example number 3, we're just going to start using that process. Here's one term, here's two terms. So we're going to take the x and multiply that by 2. The adding stays in the middle, and then we're going to take the 2 and multiply it by the 8 also. But all the terms inside parentheses will get multiplied by the factor outside of the parentheses. So now we go ahead and do what we had just wrote. So 2 times x would just be 2x, and then 2 times 8 is going to be 16. So 2 is the coefficient, and 16 is the constant in this expression. So we have x and 12 are the two terms inside this group. So we're going to take it out of the group and then give each one of them a 3. So 3x and 3 times 12, and then subtraction is going to stay right there in the middle. So we got 3x minus 36. So we're not solving anything. We're just writing equivalent expressions, just another way to write it. Okay, so the next example, we just went over an example here in class. For example, if we had 10 months and 10 months we're making money, and then we're also spending $9 on a membership, like Prodigy membership. So that means we're going to take those 10 months and then multiply it by the $9, and we're going to multiply it by how much money we're making. So if we were going to solve, we do 10x minus $90 over 10 months for an example. Okay, continue with the next example. So there's x inside the group and 15. So we're going to take them out of the group and then give both of them a negative 3. There's subtraction in the middle, so we're going to leave that in the middle. So now we have negative 3 times x. So whatever x is, it's being multiplied by -3. And then we have -3 times 15, which is going to be -45 with subtraction in the middle. So integer rules, a negative times a positive is going to be negative. But then we go to subtraction. Subtracting negatives is the same as adding the opposite. That is following the keep change rule. So the equivalent expression would be -3x plus 45. All right, going to the last few examples. We're going to take x out of this group, and then we're going to take 3 out of this group. Now that we've taken x and 3 out of the group, we're going to put a 4 with the first term and a 4 with the second term. Now we write an equivalent expression, 4x plus 12. If you wanted to rewrite this with 10 on the front side, that would be the same thing. It would be an equivalent example. So we have x times 10 minus 2 times 10. Both things get multiplied. So we got 10 times x, just 10x minus 10 times 2.